let's go ahead and get started on it. 8.2, we actually get into the trigonometric functions, and this is where you start doing the sine and the cosine, going over the distance formula, which is the Pythagorean theorem. Make sure you write the resultant vector is always going to be the square root of x squared plus y squared. That is, again, your. Now, let me go ahead and tell you, right angle trig is all based on who? Pythagoras, okay? Everything is based on Pythagoras. So therefore, everything is going to be derived from a squared plus b squared is equal to c squared. So you need to go ahead and write that down. A squared plus b squared is equal to c squared. And everything, as far as distance-wise, is going to be based on that theorem. So here you see r squared is equal to x squared plus y squared, which is just different variables. Take the square root of both sides, take the square root of both sides. R is equal to the square root of x squared plus y squared. If you want to put c is equal to a squared square root of x, I don't care, okay? And the reason they put it in terms of r is this is what we call the resultant vector. You're going to see the resultant vector later on. You usually see it in second semester or first semester physics, second semester calculus. You're going to see it a good bit. So that's where that comes from. And we also know that the resultant vector is a distance, so therefore it is never what? It is never negative because it is a distance. Oops. All right, here we go. Sine, cosine, and tangent. Now, I'm not going to tell you you have to memorize it because really you don't. You only have to know the first three. And I'm going to show you how I learned it because I didn't learn it, written linearly like that. I had it written vertically. Okay, that's the way I learned it, and I'll show you how I did that. I'll just go ahead and show it. Again, this is kind of a review for some of you. Sine, cosine, tangent, and that's all you have to remember. Oscar had a hunk of apple. Okay, if you know those, then you know the rest, because all they are reciprocals. Okay, the reciprocal of the tangent is the what? Cotangent. The reciprocal of the cosine is the what? Secant. And the reciprocal of the sine is the what? Cosecant. And what is the reciprocal of Oscar of apple? Apple of. What's the reciprocal of a hunk? Hunk a. What is the reciprocal of Oscar had? Had Oscar. That's the easiest way that I've learned to look. That's the easiest way that I've learned it. Okay. All you have to remember, no hiccuping in class. All you have to remember is those three right there. But what happens is students get confused. All right. Reason they get confused is because they don't know where to put the little man. Okay. If I give you an angle, that angle is right here. You put the little man there. Now, what in the heck are you talking about, Hubert? Well, the little man is always going to stand on the angle that you're wanting. And he always has his foot on two things. He always has his foot on the adjacent, and he always has his foot on the hypotenuse. I guarantee you that some of y'all have never seen the little man before, because that's something that I made up when I was a student. Okay? The little man always has his foot on the adjacent, and he always has his foot on the what? The hypotenuse. And therefore, you always know that he's always looking at the what? Opposite. Now, if you put that little man up here, his foot's going to be on the hypotenuse and the what? The adjacent, and the opposite's going to be over here. It all depends on where you put the little man. And you can put that little man anywhere you want to on the two angles. Okay? It depends on what you want to do. Now, if they ask you what theta is, and theta is down here, then you need to put the little man here, and you know that the adjacent and the hypotenuse is on each foot. Okay? And that's one thing that I kind of came up with when I was a student, and it never led me wrong. So I just figured I'd teach it in that way. And people do get confused, especially when you turn them 90 degrees. You turn a triangle 90 degrees and you say, okay, I want theta. And you put theta up there, oh my gosh, it will cause people's head to explode. All right? So always remember the little man always has his foot on the adjacent and the hypotenuse. Okay? Question, great, complaint. So let's see what they have next for us. There we go. What's next? The terminal side of an angle in standard position goes through -3, -4. Find the value of the 6 trigonometric functions. I don't care about the 6, give me the 3. Because if you can do the 3, you can do the 6. So first thing you need to do is plot the point. So plot the point. -3, -4. -3, whatever. -3, 1, 2, 3, -4, 1, 2, 3, 4. So there's our resultant vector. So that means we have a triangle. Now I tell students, don't worry about all this crap. Don't worry about all that. Okay? The reason is, if you find one angle, you can find both angles. If you find both angles, then you can figure out which one's which. So I tell students not to worry about that. Here is our triangle. I'm going to find this angle. So my little man is going right there. And that means that we got to find the hypotenuse. Well, the hypotenuse is 5. There's where you plug it in using the Pythagorean theorem. So we've got -3, -4, and 5. Sine. Oscar had cosine a hunk of apple. Tangent. Okay, so now we established this is equal to the adjacent, this is equal to the hypotenuse, and therefore this is equal to the opposite. Plug and chug. -4 over 5. -3 over 5. And what's this one? -4 over -3, which is 4/3. Now that's not where the problem is. Where the problem is when I turn that triangle around. And when I turn that triangle around, or if I put everything in a paragraph and have you draw it, that's when the fuses start to blow. And that's why you need to know where to put the little man. Okay? Now, of course, if I wanted to find out what the angle is, then I'd use the calculator to use the inverse sine. We'll get to that eventually. Questions so far? No. Okay. So everybody's good with that. Everybody pretty much remembers that from a long time ago. Okay? And there's, golly, we did it about right. Yeah. There we go. Just check my sine, cosine, and tangent. -4/5, -3/5, and 4/3. And you feel good about yourself. All right, you do that one. I just want you to find the sine, cosine, and tangent. Just don't look at the stuff they got there. Just do it. Okay? Sine, cosine, and tangent. Drop a line from that +2 straight down to that blue dot. Who does Alabama play next?
Another
Anybody
cupcake.
know? Who?
Another cupcake team.
Oh, God. Well, South Carolina, Georgia, and Clemson, they're going to have a game next week. Because they're telling what Jimbo is going to bring out. So here's our angle. There's our little man. So adjacent is positive 2. Opposite is -1. -1 is the opposite. And 2 squared is 5. Square root of 5. What does it come out to be? Square root of 5? Mm-hmm. So square root of 5 is the opposite. Sine, Oscar had. So that means -1 over 5.
You said 2 of them are opposites. You said 2. You just said that both of those were opposites. The square root of 5 and the -1.
I popped you, so I'm sorry.
Sorry. I was just wondering.
That's all right. Then I don't know what I was thinking of. It's the drugs. -1 over 5, and then cosine. Oscar had a hunk, so that's going to be 2 over square root of 5. And then tangent is equal to of apple, be -1 over 2. Now we're done, right? No, we're not done. Why? Because you cannot have a radical in the denominator, so you need to rationalize the denominator. So we're going to get negative square root of 5 over 5 and 2 square root of 5 over 5 and -1/2. So these are your answers. Did Oconee just come back again? Oconee, are you there?
Yeah, sorry, I didn't realize my mic was muted. Hold
You
on.
must have came in late because I took you out because nobody showed up.
Well, it was trying to get me on another call for whatever reason.
Go ahead and hit the camera so I can at least see you, okay?
Wait, I thought I did.
Just hit the camera down at the bottom and it should say turn on camera, say yes or whatever. So the sine is equal to, there you are. I just love seeing that blue background. Yeah, that's it. Sine is equal to whatever. I'm not going to do the y over r. It's the same no matter which point you find it at or whatever. So, and we'll be finding the angle here shortly. So kind of give everybody a heads up on that. I'm not going to. And there is your, and you don't have to actually learn it. I mean, you don't have to memorize it. Just remember that, just remember your graph. Just remember you got 0 here, you got 360 here. You got 90 here, you got 180, and you got 270. If I wanted to plot this point right here, then basically I would be going what? 1 in the what direction? X direction. And what? 0 in the Y direction. All right? And you got to flip it because it's the opposite with the sine and the cosine is opposite. So this is going to be 0, 1, sine and cosine. Sine and cosine. Same thing up here. What is this one? You go in the X direction 0, in the Y direction what? 1. And then you flip it. So to plot this point, it'd be 0, 1, but the sine and cosine is the opposite, so that's going to be 1 and 0. And so on and so on. So you don't necessarily have to remember it, you just have to plot it and then flip it. Okay? And of course, once you can do that, then you can fill out the other ones that I'm really don't, concern yourself. I would suggest probably you need to just memorize or learn those right there, and those will fall into place. So make sure you know those first. And really, it's not that big a deal. It's just you're going to put it on the unit circle whenever you fill out the unit circle. All these, and 360 is the same as 0, so you just have to remember. You just have to pretty much remember 3 because 2 of them are the same, and that's just a negative, and this is a negative. So it's really not a lot of memorization. You just have to plot up here. And you know, okay, this one is what? -1 and 0, and then what do? Flip it. 0, -1. This one is 0, -1, flip it, -1, 0. And then what's the undefined of 0? What's the reciprocal of 0? Undefined. And what's the reciprocal of undefined? 0. So it's pretty self-explanatory. I don't spend a lot of time on this, because, like I say, it's pretty self-explanatory if you do the plotting. Okay? You just flip it. All right, your first reciprocal identities. Put a star beside them, highlight them. 150% important. Write them down. Write them down. Make sure you learn these. If you don't, you're going to suck at the rest of the semester, and if you suck at the rest of the semester, you're going to suck in calculus. So you might as well just go ahead and quit if you don't learn these. These are the first reciprocals. These are the first identities that you're going to learn. And they're not that big of a deal, because what's the reciprocal of the sine?
It's opposite.
The cosecant is the reciprocal of the sine, so you just put 1 over the what? The cosecant. All right, what's the reciprocal of tangent? Cotangent, so you just 1 over the cotangent. And then it's the reverse. So it's not like you have to memorize them. You just have to, take your handy-dandy list. Sine, cosine, tangent, the reciprocal of the cotangent, secant, and cosecant. Well, the reciprocal of the sine is cosecant, so that's 1 over the cosecant. Oops. Reciprocal of the cosine is secant, so that's 1 over secant. The reciprocal of the cotangent, and then bisecant. What's the reciprocal of the cotangent? Tangent, so the reciprocal identity would be 1 over the tangent. I'm not going to write theta because y'all know this x. I'm not going to, you got some of these teachers, oh, well, you did the whole problem right, but you wrote cosecant. You didn't write cosecant theta, so I'm going to mark the whole problem wrong. No, I'm not one of those teachers. Okay? As long as you get the gist of the identity, because when you get to working with identities and you start reinventing the wheel with an identity, and we're going to go through that, where you take this identity and you get this identity over here, I don't really care whether you put theta on every line. All right? You're going to be thinking about reciprocals, not, oh, well, did I put a theta after that? No, you're not. You're going to be thinking about the reciprocal. All right? Not the reciprocal, but the identity. So make sure you understand those identities and how the relationship between each other, the reciprocal of the sine is cosecant, so the reciprocal identity would be 1 over the cosecant. Okay? Again, do not have to, actually all you have to memorize is that right there, and if you know this right here, then you can do the reciprocal for the first 3, and then the reciprocal for the first 3 is the reciprocal of the last 3. Hopefully, some of you are learning that you don't have to memorize your way through trig. You don't. There are some things that you do need to memorize, but not right now. Find the sine if the cosecant of theta is blah, blah, blah. Well, first of all, This is how you're thinking. Okay, let's go back to the original. Sine, cosine, tangent. Let's just go back to the original. Sine, cosine, tangent, cotangent, secant, and cosecant. And we've got the cosecant. Oscar had a hunk of apple. Oscar had what? Had Oscar. So we've got the hypotenuse, and and what cannot be negative? The hypotenuse is a distance, so it cannot be negative, right? Yeah. Yes, Hubert. Okay, so we know that negative goes with the what? 2. And write down. I want you to highlight that -2, and I want you to say, out to the side, for those of you that suck at this, you need to say, negative goes with the 2 because the hypotenuse cannot be negative. The distance cannot be negative. Okay, make sure you write that. And again, I'm talking to those people that hasn't had trig in a while. You need to highlight it, and you need to put a note there. This is a hypotenuse. The hypotenuse has to be, well, actually, it's not positive or negative. It's a distance. But we're not getting into that. But it's always going to be the what? The positive. So therefore, the -2 is the... So therefore, the sine is going to be what? -2 over what? Square root of 12, Hubert, which multiply by the square root of 12 over 12. And that's going to be equal to, and I can't write over here, but anyway, that's going to be -2 square root of 12 over 12, which is negative square root of 12 over what? 6? Something like that? Is that what they wanted to sign? So your answer would be negative square root of 12 over 6. And again, I didn't memorize anything. All I did was write down sine, cosine, tangent. Everything revolves around that list. I don't want to leave anybody, but I don't want to be spinning my wheels, okay? Okay, they did something totally different. What did they do? Oh, they used the reciprocal. Okay. Which, if you broke the square root of 3, you broke the square root of 12 up, you can break the square root of 12 up into what? Square root of 4? Damn Russians. Of course, it wasn't operator error. It's damn Russians. Here we go. All right. Take the square root of 12 and break it up. Square root of 4, square root of what? 3 over 6. What's the square root of 4? 2 square root of 3 over 6, which is square root of 3 over what? What'd they get? Okay, they just kind of skipped some steps. They said y'all know how to do it, so they skipped some steps. Comprende? Yes, Hubert. Thank you for the interaction. Appreciate it. It's always good to have interaction in class. It makes the class go by a whole lot faster. Okay. Okay. Easy way. All students take what? It's your parents' fault. All students, actually it's your high school teacher's fault. All students take what? Calculus. All students take calculus. Remember that. So every trig function in the first quadrant is what? All positive. All are positive. Student stands for the sine and the what? What's the reciprocal of the sine? Cosecant. Cosecant. Students, that means these two are positive. Take means tangent and what? Cotangent. Cotangent, they're the only two that's positive. Everything else is negative. And calculus, the cosine and the what? Secant. Secant are positive. And that's what this chart is saying. All students take calculus. I'm very, very amazed that people have not heard of that. And you took pre-calculus. Okay, you forgot, but you have heard about it. Thank you. I haven't. Well, that is something that's been taught since the beginning of time with calculus. All students take calculus.
Because not all students take calculus now.
Yeah, they have underwater firefighting.
Yeah.
Take underwater firefighting, that way you can't get a job when you get out of school, and that way you fuss at the government for not paying for your student loans.
At my school, they're like, you can take pre-cal or you can take problem stats.
Oh, yeah. No, shut up, Hubert. Shut up, Hubert. Shut up. Okay, we're not going to talk about that because I'm not going to get in trouble. I can't get out of this, but that just amazes me, though. People, my mouse is not working. He's Russian. It's Russian.
Oh, those Russians.
Okay, well, anyway.
Russians let up.
There we go. All students take calculus. And here, and we're fixing to get into the special angles, or hopefully. If you'll notice, and now I think what they're talking about here is basically what's going to happen to your hypotenuse when your angle increases, what's going to happen to your opposite, and I'm not going to go over that because that kind of confuses people. But as you can see, as your angle increases in the first quadrant, your y is going to what? Increase, which means your x is going to decrease. And I'm not going to insult your intelligence by going over that. Hopefully you can see with those 4 pictures right there that as your y increases, your x is going to decrease. But your hypotenuse is always going to be your longest what? It's going to be positive, and it's always going to be your longest side, and it's always opposite from the 90-degree angle. Always. Okay, again, I'm covering some of this. I'm trying to not to step on anybody's toes and insult anybody's intelligence, but I'm just trying to feel everybody out. I'm trying to see what you know, what you don't know. If you got any questions, pick it out or spit it out or send it to me. Ask my instructor, okay? All right, decide whether each statement is possible for or impossible. Okay, for any angle of which the indicated function exists, -1 is sine of theta is between -1 and +1, and -1 and the cosine is from -1 to +1. Okay, tangent and cotangent may be equal to any real number. Secant, okay, blah blah. I'm not going to go through that. Okay. Sine of theta is equal to 1.7. Possible or not possible? Come on, people.
It's not possible, right?
It's not possible. Why?
Because it's greater than
More than 1. 1.7. Square root of 3. Put it in your calculator, people. Trying to get y'all to interact. Thank you for the one person penalty that interacted. It is not possible because square root of 3 is 1.7. It's kind of like in the last class, I did f of x is equal to 3/2 x squared. And I asked everybody, I said, is this wide or skinny? And everybody went wide because it's a fraction. But it's not a proper fraction, it's a what? 3/2 is a what? Improper fraction. It's more than 1.
Right.
Just like square root of 3 is more than 1. Tangent, so look at the tangent, may be equal to any real number. That's possible. Secant. Secant has to be between what? It has to be less than -1 or greater than 1. So that's impossible because less than 1 would be -2, -3, -4. So that's impossible. What they are trying to get you to realize is sometimes, what are these called up here? Starts with a R. They're called restrictions. All right? Sometimes they're going to give you restrictions on the quadrant that you can find the what in? The answer in. Write that down. Okay? Sometimes you will be given restrictions, and what they're trying to get you to realize here is they are giving you restrictions on your possible solutions, which basically narrows down to one word, quadrant. They're telling you what quadrant the solution is in. That's what they're telling you. So you have to read those restrictions, because if you're on a test and you're doing your test and the answer is 225 degrees, but you put 45 degrees, Is that answer incorrect? Yes, because you're in the wrong one. Quadrant. They're telling you restrictions matter. Now, I know some of y'all that, that belong on live PD, sir, I caught you doing 85 and a 35, but I wasn't going 85. Okay, whatever. Any of y'all ever watch live PD?
Yeah.
These people do nothing wrong. It's all about Russia, okay? They do nothing wrong. They didn't have their speakers loud. They're not carrying 5 pounds of marijuana, and they didn't go 50 miles over the speed limit. They do nothing wrong. Nothing. It's all Russia. It's all the mean cops. 3 new identities from, what is that? The Pythagorean theorem. Okay? They're basically reading up to the Pythagorean identities, which, if you want to write that down, no, don't write it down, because all that's going to do is confuse you. Write down the Pythagorean identities right there. Sine squared plus cosine squared is equal to 1. The number 2 that you need to memorize. I usually don't tell you if you have to memorize something, but here you need to memorize. That's the second box that you need to memorize. First one is the reciprocal identities. The second one is the Pythagorean identities. Remember me telling you that you're not going to get rid of shortcuts 1 through 5, not until you get your degree in engineering or whatever the case may be. Guess what? You're not getting rid of these until after differential equations. All right? You're going to be seeing a lot of this in Calc 2, a lot of this in Calc 3, and a lot of it in Calc and Diff-EQ. So if you want to go ahead and quit and get a degree in underwater firefighting, go ahead, because you're not going to get rid of these. So you might as well learn them. And I mean learn them verbatim, not no half-ass. You need to learn them, and you need to learn them down to every little line, all right? Because you need to know them quick. Sine squared plus cosine squared is equal to 1. And then you need to say, okay, sine squared is equal to 1 minus cosine squared. Cosine squared is equal to 1 minus sine squared. You need to be able to rattle them off, okay? Because if you don't, you're going to be on number 2 when everybody else is finishing the test, okay? Quotient identities. Just write what's in the blue box, okay? Now, you can actually see that you're multiplying by the reciprocal, and that's fine and dandy, but that's really not going to help you try to remember them. Out of the 3 sets of identities, the second and the third are the most used. The second and the third are the most used. So the reciprocal identities and the quotient identities are the most used in trig and first variable calculus. The reciprocal identities are the most used in second and third semester calculus. Third semester calculus really is nothing but plugging and chugging after you find the derivative and the antiderivative. Third semester calculus, you're given a bunch of formulas. You don't know you're given a bunch of formulas till after the fact, but after you finish, you figure out, hey, all we were doing was plugging the first and second and third derivative into a formula. Yeah, and in third semester calculus, you actually derive some of those formulas by using the reciprocal identities. No, not the reciprocal. The Pythagorean identities. Okay, so here we go. Find the sine theta and cosine theta if tangent of theta is equal to 4/3 and theta is in the quadrant 3. All right, I want you to write that down, and I want you to do it. The first thing, and this is true in calculus, it's true in physics. Draw a what? Draw a picture, yes. Draw a picture. Well, what do you mean draw a picture? I don't know. Oscar, add a hunk of what? Apple. Of apple. So you've got the opposite, and you've got the what? Of apple.
Adjacent.
Thank you. Thank you for the interaction. I appreciate that. The rest of y'all are hit on bull. I actually had a person tell me that I shouldn't use the word tit on a bull. What do you call those four things hanging on a cow? That's what you call them. I mean, that is the scientific word for them, not the word what y'all thinking of, but that's what they're called. So I'm sorry. Get a puppy or a stuffed animal if you're going to come to my class and get offended. 4/3. Okay, here we go. I'm not even worried about this right now. Why am I not worried about that? Because that can come later on. You just need to find the what? You just need to find the answer. All right? So, tangent is 4/3. Tangent is equal to, Oscar had a hunk of apple. All right? Now, the reason I do this, and the reason I'm saying everything out loud, that's what you need to be thinking. I'm not doing it because I'm thinking of this. I can do it in my head and not say a word. Okay? But I'm doing it because that's what you need to be saying to yourself. Okay? That means 4 is the opposite and 3 is the adjacent. And, okay, so I'm going to just put this here. They're both positive. So I'm going to put that right there. That's the adjacent. That'd be 3. And then 4 would be what? Opposite, which would be here. So that means my angle is right here. And my little man is standing right there. So 3 squared, let's see, R hypotenuse is equal to 3 squared plus 4 squared. And that's going to be h is equal to the square root of 9 plus 16, which h is equal to 25, which h is equal to 5. So you put that there, and then you go, okay, well, sine is equal to what? Sine is equal to Oscar had, so that's going to be 4 over what? 4 over 5. And cosine, Oscar had a what? A hunk, well, that's going to be 3 over 5. But the problem is, that's in the what quadrant? That's in the first quadrant. So now you just did this. So mark that out. Now you just have to say, okay, now I'm going to flip it. Instead of being down there, it's going to be where? Down here. And this is going to be negative what? This is going to be negative 4, and this is going to be negative 3, and this is going to be positive what?
5.
And now you just put the signs in where you need to. So 4 over 5 is going to be negative 4 over 5. And this right here is going to be negative 3 over 5. So here, I did that. Or you could say all students take what? Calculus. And then you could say, well, here everything's like this, but in third quarter, the tangent, so therefore it's going to be negative. My two answers, this is going to be negative, and this is going to be negative, because the only thing positive here is what? Tangent and the cotangent. So you could think that. I don't care which one you do, okay? But just make sure you know why on both of them. Capiche? Now, like I said, there's not a lot of memory here. It's a lot of drawing everything out and extracting the information. The only thing that I've told you to memorize is those 3 boxes so far. And we've gone over 2 sections. I've only told you to memorize 3 things.
Do you mind if we do one more?
Say again?
Do you mind if we do another one of those?
Yeah, let's, okay, that should not be, yeah, do it in the second quadrant. Hold on just a minute, this phone call. Hello. Hello. It's odd. This is an odd phone call. in the second quadrant, see what would it be. Find the sine and the cosine in the second quadrant. I'm gonna make this phone call because that's the phone number that it doesn't supposed to call.
Please.
It's climate. Climate. See what you talking about?
That's great. Call the person back and they say, this person is unavailable. Don't make any sense. This is my daughter. But she don't call. Okay, in the second quadrant, I'm just checking to see if so long as she takes me back. Okay, in the second quadrant, you have negative what? So I'm going to take my red pen here, and in the second quadrant, I've got what? Negative 3 and positive what? Positive 4. So remember, what is positive in the second is going to be sine and what? Cosecant. Sorry.
Oh, cosecant.
Oh, whatever. Cosecant. So they want the sine and the cosine, so my sine is going to be what? Positive, so that's our answer for that one. And the cosine is going to be what? Negative, so it's going to be that one. So in the second quadrant, you're talking about 4/5 and negative 3/5. Now, when you asked that question, you asked me to do it again. Was it from a quadrant, or was it from a quadrant view, meaning which quadrant, or was it from a how did you turn 4/3 into whatever? Which way were you coming with that question?
How you turned 4/3.
Okay, all right. Then let's go back and let's make one up. And I'm going to erase what we got here. And I'm going to change the 4/3. Let's change the 4/3 to 5/2.
Well, tell me you got this one again. 12:30.
Okay.
Go ahead and do 5/2.
You want to change the quadrant?
No. Okay, she texted me back, so she's not dead or anything. Okay, so here we draw a picture. I'm just going to draw it in black. And I draw a picture here and I say, okay, tangent is equal to Oscar had a hump of apple, which means 5/2. So I draw my handy dandy graph and I say, okay, that's opposite. So my triangle's in the first quadrant. I know that because whenever you're finding anything, start in the first quadrant first, and then you can figure out where it's asking, once you find the answer, you can figure that out with either all students take calculus, or you can figure it out by putting the negatives and the positives. Either way, I don't care. All right, so my opposite is 5, so my little man is right here, so my opposite is over here, and my adjacent is 2. So therefore, the hypotenuse is equal to the square root of 5 squared plus 2 squared, and that's 4 plus 25, which is what?
Where?
29, the square root of 29, and we're just going to leave it as the square root of 29. Is that good? Yes. And in trig and in calculus, I'll tell you when the real world, yes, you're not going to leave it square root of 29 in the real world. But in trig and calculus, you're going to leave it as square root of 29. So you can rationalize the denominator, so that'll be it. So don't change it to, let's say that'd be 5.3 or something like that, because 25 is 5.5 or 5. So that's going to be about 5.3, maybe 5.27 or something like that. Anyway, now I've got all my parts. Now I'm going to say, okay, they want the sine and the cosine. So I'm going to go over here and I'm going to say sine is equal to Oscar pad, cosine is equal to a hunk. So I go over here and I say opposite is 5, and adjacent is what? 2?
Yeah.
Oscar had. I'm sorry. Oscar had. I'm sorry. I can't read my own writing. Square root of 29. There we go. And adjacent is 2 over square root of 29. Now you need to rationalize the denominator. And that's going to be 5 times square root of 29 over what? 29. So that's one answer. And 2 square root of 29 over 29. When I'm using my finger, it messes it up a little bit. That's why I couldn't read my own writing over here. All right, so that's our answers. Now, that's in the first quadrant. All students take calculus. All right, they're asking for quadrant 3. Quadrant 3, the tangent and the cotangent are both what? Positive. So that means everything else is what? So you put a negative here and you put a negative there. Or you draw it and say, well, they want the third, so it's got to be, and I'm going to do this. I'm going to write it in red, and I'm going to go, okay, so that means that'd be a negative 5 here and a negative 2 here. So that's negative 2 and a negative 5. And that's going to be square root of 29 here. And then you go, okay, that's going to be negative 5 over 29. And then that's going to be negative 2. I'm doing it 2 different ways here for y'all. And then you say, okay, that's going to be a negative 5 here and a negative 2 there. So there's your answer. So you can do it as you're drawing it in the third quadrant, or you can do everything in the first quadrant and then just use all students take calculus. Does that help? Pendleton, does that help? I think that question came from Pendleton, right?
I think you put the numbers in the wrong spot.
Yeah, was that supposed to be a negative 5? I mean,
The 2 and the 5 are wrong.
yeah.
The 2 and the 5 are wrong. X should be negative 2.
Oh, okay. Yeah, I see. Yes, you're right. Negative 5, sorry, and negative 2. Okay, you have to look over the dyslexic. Sometimes I go dyslexic. You just have to look over it. I try to take drugs, but sometimes I take too many.
So, do you always start in the first quadrant, basically?
I always do. That's just me. Always, because this right here is the actual math right here. Okay? That's the actual math.
Yeah.
And then this is what? The orientation, where you can use all students take what? All students take calculus. So I don't care how you do it. Who asked that?
Oh.
Pendleton or who asked that?
Pendleton.
Yeah. You can do it now. You can draw it in the third quadrant if you want to. That's up to you. You can draw it in the first quadrant, do the math, and use all students take calculus. You can draw it in the third quadrant and not do all students take calculus. Or you can do it in the first quadrant and then flip it over and draw it in the second quadrant. Whatever you want, third quadrant, whatever you want to do.
So if I was asking for in quadrant 4, you'd start in quadrant 2?
If it was asking in quadrant 4, then I would just drop it down right here.
Okay.
Like that.
Okay.
Or
So
I would
just start in
say,
quadrant
if
1.
they were asking for quadrant 4, then I would say, okay, all students take calculus, so the cosine would be what? The cosine would be positive, and the sine would be what? Negative. What they're trying to get you to learn is all students take calculus. That's what they're trying to get you to learn. They're trying to get you to learn that. Okay, let me check my phone because some of y'all go into convulsions. Okay, we're okay. We're at least 15 minutes away from convulsion time. Well, I'm trying to find my mouse. If y'all see my mouse anywhere, let me know. Because it has disappeared. The Russians have taken my mouse. Can't get rid of that. Y'all still see my mouse? I see stuff blinking. Y'all just bear with me.
So just unplug it and plug it back in.
I just wonder if the battery's dead. It's not moving. Do you see it? It's right there. It's a conspiracy.
The Russians have taken over.
Yeah.
You know what's sad is some people have no idea.
What's up here? Yeah. He's like, what's going on?
That's what's sad.
Yeah.
Okay.
You slipped. So, yeah.
And of course, it's a AA instead of a AAA. Everything in here is AAA except for the mouse. Just like the federal government. Y'all remember the movie Apollo 13?
Mm-hmm.
The scrubbers in one part were circular, and what's the scrubbers in the other part? Square. I can't find the exit on this dead blame thing. There it is. Okay, just hold on. I'll have to go get a battery. I'm gonna go get the battery. Y'all just have a chill pill. I'll be right back. Give that person time to complain. I'll go ahead and complain. Already on it.
Double A.
What?
There's a homework home.
But you should memorize this pre-calc. This is supposed to be my pre-calc class.
It's like, base is, but
And after that is prognosis.
Yeah. Of course. Really?
but I mean, basically, same.
You know, I'm just really learn logs.
Really?
I don't know any logs. Anytime you drop a log, like,
I learned it, and then I skipped a day, and then I just got completely fucked over after that.
I was at a week or a lot of that log.
Oh, a week too during, and he taught something. I went and I was like, what?
Oh, I could have signed into Blackboard.
I'm like, I can't understand.
I couldn't get in through OMI. I don't know why.
Alright.
I had batteries.
Welcome back.
No, I'm sorry, I didn't. No, then I have to give it to you, because then you'd say that I took your battery and didn't give it back to you. And
No, I don't.
then
care
you,
for batteries.
yeah.
Yeah. I don't think all these are right.
I don't use the battery.
Something's wrong. I see it moving.
Yeah.
If you find any more, I'll buy some.
Oh, I didn't turn it on.
There we go.
All right, we're back. So, we can go to the next
Sticky note deal.
next problem.
There's no way.
And I'll go ahead and show you what they're, well, it's just not working.
Real.
Oh, there you go.
I refuse to hook my card up to it. So,
Is that my brother's?
I say, you don't even.
There we go.
So,
Okay, so you see that the negative 5/3 is there. I tried to erase it, but it's not cooperating, so I'm just gonna move on to the next problem.
So so dead.
For those that are listening, I mean, do y'all want me to be quiet? I mean, I'll be quiet if y'all want me to. Is it okay? Can I be in charge for a while? Okay, thank you. All right, so you've got the quadrants, you've got the Pythagorean theorem, you've got the Pythagorean theorem that gives you the resultant, you've got the Pythagorean identities, you've got the reciprocal identities, and you've got the restrictions and the Pythagorean identities, the reciprocal identities, and there's one more.
Quotient.
The quotient identities. And then you've got the restrictions that they put on the quadrants. So in 8.2, those are the 4 things that are happening in 8.2. All right? I'm going to hold off on going on 8.3 because I still feel like some of y'all are still catching up. So I'll go ahead and we'll call it a day today, even though I'm letting y'all out a little bit early. I don't want to see any of y'all go into convulsions. I'll call the penalty campus first.
I heard 8.1.
Pendleton campus, 9.
Just gotta get one. But
4.
It's called roll.
I was stuck in
Armstrong,
something. I figured
Here.
it out, but I just haven't got it.
Bitely,
Here.
Brown,
Here.
Harlan, Cunningham,
Here.
Evans,
Here.
Gusmus,
here.
Leviner,
Here.
Austin,
Here.
Nitz,
Here.
Rudiger. Why did she say here? Rudiger?
Yes, I'm here.
Okay. Santana Flores.
Here.
Schaefer.
Here.
And Radford.
Here.
Okay. Miss Crittenden, I got you down. Easley campus. R. Blaster.
Here.
Cody.
Here.
Dove. Sexton.
Here.
Swords.
Here.
And Pendleton campus. Orocho. Bennett. Gillespie. Hither. Either. Lee is here. Lindsay. McGahey.
Here.
Nettles.
Here.
Reese.
Here.
And Shingleton.
Yes, sir.
Anybody got any questions? Of course, Pendleton's already left. You tell the bridge students. Golly, they're rude. All right, y'all have a good one. If you got any questions, give me a holler.